Most people walk right past them. They sit quietly on dirt roads, desert hillsides, riverbanks, and abandoned mine dumps. Dark, heavy, rough-looking rocks that seem completely ordinary. Children kick them aside. Hikers step over them. Prospectors sometimes toss them back into the pile without giving them a second thought. Yet some of these strange black stones have traveled millions of miles through space before crashing into Earth. Others form deep inside our planet under incredible pressure and heat. The surprising part is that many experienced hunters begin their investigation with one of the simplest tools imaginable: a magnet. But here's where things become interesting. A magnet can save you years of frustration. It can prevent costly mistakes, and occasionally, it can lead someone toward discovering something truly extraordinary. But magnets can also fool people. Thousands of individuals have become convinced they discovered a valuable meteorite simply because a rock stuck to a magnet. Most of them were wrong. Today, we're going to uncover why prospectors, meteorite hunters, and mineral collectors almost always carry magnets into the field. You'll learn what a magnet can reveal, what it cannot reveal, and why some black rocks deserve far more attention than people realize. Because the next time you pick up an unusual stone, you may look at it very differently. Human beings naturally associate unusual objects with treasure. It's easy to understand why. Movies show meteorites containing precious metals. Internet articles highlight stories of farmers finding rare space rocks worth thousands. News headlines occasionally mention collectors paying enormous sums for unique specimens. These stories create excitement, but they also create misconceptions. The biggest mistake beginners make is assuming that every heavy black rock must be valuable. In reality, Earth produces countless dark rocks: basalt, magnetite, hematite, gabbro, diabase, slag from industrial processes, old furnace waste, mining debris, iron-rich concretions. These materials can all resemble meteorites. Some even react strongly to magnets. And this is where people become confused. A magnet does not identify meteorites. It identifies magnetic minerals. That's a very important distinction. Think of a magnet as a detective. It points toward clues. It doesn't solve the case. Experienced hunters understand this. They know that every clue must be examined carefully. Weight, surface texture, color, streak, density, magnetic response, shape, internal structure. Only by combining multiple observations can someone begin determining whether a specimen deserves further investigation. And surprisingly, some of the best discoveries happen because someone was curious enough not to throw away a strange black rock. Why prospectors always carry magnets. Walk alongside experienced gold prospectors. Spend time with meteorite enthusiasts. Visit mineral collectors. You'll notice something interesting. Many carry magnets. Some wear powerful rare earth magnets around their neck. Others keep telescoping magnetic tools in backpacks. Some attach magnets to walking sticks. Why? Because magnets provide immediate information within seconds, without damaging the specimen. No chemicals, no expensive equipment, no laboratory. Simply place the magnet near the rock. Observe. Does it attract strongly, weakly? Not at all. Does only one portion respond? Does metallic dust cling to the magnet? These details matter. Meteorites containing iron and nickel frequently show magnetic attraction. Magnetite-rich rocks also respond. Certain mining wastes exhibit powerful magnetic properties. Even some volcanic materials react. The magnet serves as an inexpensive filter. Instead of transporting hundreds of rocks home, hunters can narrow their selections. It saves time, energy, and storage space. But professionals rarely celebrate after seeing magnetic attraction. Instead, they become cautious because they understand another important fact. The majority of magnetic rocks found on Earth are not meteorites. One mineral causes more confusion than almost any other. Magnetite. Magnetite is fascinating. It possesses strong magnetic properties. It often appears black, sometimes metallic, occasionally shiny. It can feel surprisingly heavy. To inexperienced collectors, magnetite looks promising. Many people become convinced they've discovered space material, but magnetite is common, very common. Entire mountain ranges contain magnetite deposits. Old mine dumps may hold massive quantities. Beaches sometimes concentrate magnetite into black sand layers. Volcanic regions produce magnetite-rich rocks. Streams transport fragments downstream. Nature scatters magnetite almost everywhere. Yet magnetite remains highly desirable. Industrial companies use it. Collectors appreciate it. Scientists study it. Prospectors pay attention to it. Why? Because magnetite can occasionally accompany valuable mineral systems. Gold districts sometimes contain magnetite. Skarn deposits frequently include magnetite. Iron-rich alteration zones may host economically significant minerals. Finding magnetite doesn't guarantee treasure, but it can indicate interesting geological conditions. And experienced prospectors love following clues. Imagine hiking across an old hillside. Loose gravel crunches beneath your boots. You notice an unusual rock. Dark gray, heavy, smooth in certain places, rough elsewhere. You pick it up. It feels denser than expected. You test it with a magnet. Attraction, not extremely strong, but noticeable. Should you become excited? Maybe. But now the real investigation begins. Experts immediately ask questions. Does the specimen display a melted exterior? Does it possess thumbprint-like depressions? Is there rust staining? Can metallic grains be seen? Does the surface resemble industrial slag? Could it have originated from nearby mining activities? Does it show bubbles? Meteorites rarely contain gas bubbles. Industrial slag often does. Tiny observations make enormous differences. This is why patience separates experienced hunters from hopeful collectors. Good discoveries reward careful examination, not wishful thinking. Every year, fascinating discoveries remind us that unusual rocks deserve respect. Farmers uncover strange stones while plowing. Metal detector enthusiasts stumble upon dense metallic masses. Children find curious objects in fields. Hikers notice oddly shaped specimens along trails. Sometimes experts confirm meteorites. Sometimes they identify rare terrestrial minerals. Occasionally, they discover historically significant specimens. These stories inspire people, but experienced hunters understand something important. Great finds rarely happen because someone expected treasure. They happen because someone paid attention. Curiosity matters. Observation matters. Patience matters. And sometimes, carrying a simple magnet matters. Because even if 99 unusual rocks turn out to be ordinary, the 100th might teach you something remarkable about geology, mining history, or perhaps even our solar system. So far, we've learned something important. A magnet isn't a treasure detector. It is a filter. It narrows possibilities. It encourages further investigation. But experienced hunters know that once a rock passes the magnet test, the real work finally begins. And this is where patience starts separating serious hunters from people chasing wishful thinking, because history has shown us that valuable discoveries almost never announce themselves. Instead, they often hide behind appearances that seem completely ordinary. Some of the world's most interesting meteorites were discovered by accident. A prospector picked up a strange black rock simply because it felt heavier than the surrounding gravel. At first glance, none of these people thought they had found anything extraordinary. They simply became curious enough to ask questions. And curiosity remains one of the most valuable tools any hunter can carry. If your specimen responds to a magnet, the next step is simple. Study the surface. Meteorites often develop what scientists call a fusion crust. Imagine an object entering Earth's atmosphere at tremendous speed. The outer surface becomes intensely heated. The exterior melts. As the object slows down, that molten skin cools rapidly. The result is usually a thin, dark coating, sometimes smooth, sometimes slightly cracked, sometimes weathered, but generally distinct from the interior. Meteorites may also display shallow indentations. Collectors often compare them to thumbprints pressed into soft clay. Scientists call these features regmaglyphs. Not every meteorite shows them clearly. Weathering can erase details, but when present, they immediately attract attention. Then comes density. Many meteorites feel surprisingly heavy. People often say they feel wrong for their size. A stone no larger than a fist may weigh far more than expected. That unusual heft should never be ignored. Another important clue involves the streak test. Take an unglazed ceramic tile. Gently rub a small inconspicuous area. Magnetite usually leaves a black streak. Hematite often leaves a reddish-brown streak. Meteorites generally do not behave this way. Small observations like these can prevent expensive mistakes, and mistakes happen more often than most people realize. Thousands of people proudly post photographs online every year claiming they found meteorites. Experts review them, and in most cases, the answer is disappointing. Industrial slag, railroad debris, furnace waste, basalt, magnetite, iron concretions, ordinary terrestrial rocks. But occasionally, someone gets lucky. Very lucky. Experts confirm the specimen. Laboratories analyze it. Nickel is detected. The structure matches extraterrestrial material. The owner suddenly realizes they have been holding an object older than Earth itself. An object that traveled through space for billions of years. Think about that for a moment. Before humans existed, before dinosaurs walked the planet, before complex life appeared in Earth's oceans, that object was already drifting silently between planets. Eventually, gravity altered its journey. It entered our atmosphere, survived the descent, and waited patiently for someone curious enough to pick it up. That possibility keeps meteorite hunters searching. Geology itself is fascinating. Magnetite can indicate iron-rich systems. Skarn environments may contain economically important minerals. Ultramafic rocks can host chromite. Ancient mining districts preserve clues about Earth's dynamic history. A heavy black rock may not make someone wealthy, but it can teach them how landscapes evolved, how minerals formed, how prospectors think, and why observation remains more powerful than luck. This is precisely why experienced hunters rarely rush. They don't assume, they investigate, they compare, they document, they learn. And perhaps that's the biggest lesson hidden inside every unusual stone. Treasure hunting isn't really about treasure. It's about training your eyes to notice details others overlook. Most people walk past black rocks every day. Some kick them aside. Some never bend down. Some never ask questions. But a few individuals stop. They look closer. They test. They study. And occasionally, they discover something remarkable. Not because they were lucky. Not because they possessed expensive equipment. But because they were willing to remain curious. So the next time you encounter an unusual black rock resting quietly along a trail, hidden among old mine tailings, or lying unnoticed beside a dirt road, don't immediately assume it's worthless. Take a closer look, feel its weight, examine its texture, try the magnet test, ask questions, research, learn. Because while most black rocks will never be meteorites, the habit of paying attention can lead you toward discoveries that are far more rewarding than money alone. And sometimes, the most extraordinary stories begin with an object everyone else decided to leave behind. Have you ever found a strange black rock that responded to a magnet? Tell us where you found it in the comments below. Here at Gem Hunters, we explore the hidden clues that nature leaves behind. One rock, one crystal, and one discovery at a time. Stay curious and we'll see you in the next hunt.